If you examine this particular displacement function, you notice two things about it. First, that it is a parabolic function, and secondly, that the negative sign in here indicates that the parabola is a downward shape. It means it has a maximum. So if we were to draw this parabola up like this, the displacement of this, we might say that this is the displacement of the device. But we all know also that this device was thrown, and I mean thrown, not dropped, from a jetty. So it did not begin its path from the bottom here, and also it will not be thrown from the very maximum. Now let's presume that it's thrown into the water. Let's make the water blue, and this is our water. And the person is standing on a jetty and throwing that device over. Now we know, like I said, it's not dropped, it's thrown. So our timeline will start from here, and our axis would continue here. And the device will reach the water at k seconds. So what we want to do is find out this time span in seconds, where time is less than, or t is less than this, and go greater than 0 and less than k. And finding this value of k means that you need to find the roots of this parabola, and that can be done by by equating the displacement to 0, because that's where the roots will be found. Now this particular equation is a little bit complicated for factorization, so I suggest you use technology. That means you use your calculators. And if you do that, you actually receive two values for the time. One of them is going to be negative, and we can't use that value because you cannot have time negative, but we can use the one on the second value, which is 1.872 seconds. And our answer to this question, A, is going to be 0 is less than equal to t, which is less than or equal to 1.87 seconds. And the next part is to draw the sign diagrams for velocity and acceleration. We need to find then velocity, and velocity is done by differentiating that displacement function. So that should be, and to draw the sign diagram, we need to put this to 0, and so it's easy now to see. 4.9. Okay, just a bit of rearrangement. So we finally get t to be 4.8 over 9.8, which is really a half. Okay, this suggests that the direction of the velocity changes at 0.5 seconds. So we can now draw the sign diagram starting from t is equal to 0. It'll change at 0.5 and it finishes at approximately t is equal to 1.5887 seconds. To find out the values inside, we just need to take that 0 and substitute it in the velocity function. And if you substitute 0 in here, we get a 4.9 value, which really means that that's going to be positive. And if we get anything bigger, then we'll get a negative value over here. Now, to do this acceleration, we need to differentiate again that velocity function, and all we get is minus 9.8, and that'll be meters per second, and that is a constant. So we can draw the sign diagram for that as well, and the sign diagram will look like again from here to there, with the same t being 0 here and finishing over at 1.87, but this time we have a negative number, so the whole thing is negative. Now we want to know whether the speed of the device was increasing or decreasing after 0.2 seconds and after 1 second. So looking at the sign diagram, we are able to have a look where it is decreasing. It's decreasing here, and it's decreasing in the acceleration up here, and it's increasing in there. So when the velocity and the acceleration are opposite sign, we know that the velocity must be decreasing. And when the velocity and the acceleration are both of the same side here, then in this area over here, we know that velocity must be increasing. Hence, at t equals 0.2, which would be in this area over here below 0.5, we will know that the velocity is decreasing. And for the second part of the question, at t is equal to 1 second, we can check it on the diagram. 1 will be somewhere around here. We know that in this case, the velocity will be increasing. Done. Okay, now I'll be choosing other questions in kinematics to work, and if you like to see how the workings out of them, please subscribe, and they'll be instantly sent to you the next time I make one. And if you like me to show you specific questions you have, and I'll do a video on it.